All right, this is section 6.2. We're looking at day 2 where we're using division, and we're going to be dividing rational expressions. And this example or this video is going to include numbers only. Next video will include numbers and variables. So I've put some things down here that you can write in your notes as we follow along here. So it's steps to simplify. Being able to simplify radicals using division. Okay, so one of the first things you're going to want to do as you're looking at this is be able to write one whole root to reduce the fraction if possible. For example, you might see a number or a root that might look like this, the square root of 5 over the square root of 2. When I say write it as one whole root, what I mean is write it as the square root of 5 over 2. Write it as one whole root. You can do that, okay, as long as the indices are the same. So I want to do that first, and then what I want to try to do is reduce this fraction if possible. Sometimes that fraction will reduce for you, sometimes it won't. In this case, it wouldn't. But sometimes you might get 10 over 2, well then you can make it 5 over 1, and then it will make your roots much easier to simplify. Then, once you get done with that, okay, once you get finished with that, then you're going to separate your roots again. So, like in this example here, I don't have a number that'll go into 5 and 2, so I'm just going to separate them back out. Recognize, okay, nothing will go into them, so I'm going to go ahead and leave them like that. Now, the third step says to multiply the top and the bottom by the root in the denominator. Now, this is called rationalizing the denominator. I cannot have a square root in the bottom of a fraction, kind of like I can't have 0 in the bottom of a fraction. So in order to get the root out of the bottom of a fraction, I'm going to multiply top and bottom both by the denominator, okay? Now, square root of 2 over square root of 2 is 1. So multiplying by the number 1 doesn't change how much the value of this expression is. What it does do is it changes what it looks like. Okay, so now we're going to use multiplication. So square root of 5 times square root of 2, those two are both the same thing. I'm going to get the square root of 10 in this case. Okay, square root of 10. And on the bottom, square root of 2 times square root of 2 is the square root of 4. Now, said we can't have a square root in the bottom, okay, which is true. But now if you look, I have the square root of 10 on the top, and the square root of 4 is 2. So now you'll notice that the square root on the bottom has gone away. Now, this would be my simplified answer. Okay, this is what I'm talking about in step 4, simplify as much as possible. Okay, so that's just kind of some steps as we look here at examples of what to do here. So let's take a look here at number 1. Okay, so on number 1, again, I'll try and leave those steps up there so you can see those on this example. I have the square root of 3 over the square root of 2. So what I'm going to do real quick is just see, first of all, does 2 go into 3, or is there a number that goes into 3 or 2? No, there's not. So because there's not a number that goes into 3 and 2, I'm not going to write this as one whole root. Okay? So I'm going to go ahead and skip away to step number 2 is already separated. So step number 3, I'm going to multiply top and bottom by the denominator, square root of 2 over the square root of 2. 3 times the square root of 3 times square root of 2 is the square root of 6. And the square root of 2 times square root of 2 is the square root of 4. Or I'll even write this as 2 squared. So maybe you guys can understand this a little bit better with it too. Okay, now you'll notice, again, remember, square root and a square cancel each other. So this square root and the square cancel each other. So on the top, I have the square root of 6. On the bottom, I have a 2. Now, with division, can I cancel, like, I know 2 goes into 6, but can I cancel those 2? I cannot, because this guy's in a square root, this guy's not. This is my simplified answer with division. Okay? All right, let's look at another example. This one here. Now, is there a number that goes into 8 and 20? Okay, there is. So now what I'm going to do here is I'm going to write this as all one root, 8 over 20, because now I can simplify that fraction. Okay, so as I simplify that fraction, I need to know what's the biggest number that goes into 8 and 20. Well, that's 4. So if I divide these guys both by 4, 8 divided by 4 is 2. 20 divided by 4 is 5. Okay? So once I reduce it, then I'm going to separate them again. So this is going to be now the square root of 2 over the square root of 5. Okay, so now that I've separated them, I'm going to multiply top and bottom by the square root of the denominator, not the square root of the numerator. So square root of 5 and square root of 5. Okay, so the square root of 5 times the square root of 2 is the square root of 10. On the bottom, I get the square root of 5 to the second power because there's 2 5s. Okay, again, square root cancel each other. And this is going to be the square root of 10 on top and 5 on the bottom. Now again, does 5 go into 10? Yes, it does. But because this has a square root on it, this one doesn't, I can't simplify these anymore. This is my final answer. Okay, so now you should be able to complete the problems here on page 2 of your class kick examples.